DSPy is an unusual framework, right? I actually met up with the founder last week, like really smart guy that came out of Stanford, and they've used it internally at Stanford for a few of the other projects, like Storm, which was like precursor to deep research, was built on DSPy.
Oh, interesting.
So I'd say DSPy is like one of those kind of open secrets that a lot of people are using. Like someone went and sleuthed and found that all of the major vibe coding apps, Replit, Windsurf, like all of the CEOs follow DSPy, but they never talk about DSPy. And the reason I think is that the documentation is very academic. It doesn't really talk that much about real world business use cases, and it assumes that things like what like multi-hop is, or that you're familiar with a specific academic data set that nobody uses in the real world. So once you trudge through all of that, you'll find this actually pretty simple.
Okay.
It just looks very complicated because the people who made it are really smart, and therefore they have a bit of a blind spot, I think, in terms of making it more accessible.
Yeah.
They also settled on this weird domain-specific language that is not very Pythonic. Here is a DSPy signature, which is just, if you extract it out, it's literally just defining what the inputs and outputs are of your prompt.
Okay.
And these are the instructions, right? Extract structured information from text, right? So you can give really simple instructions.
And that ends up going into the
end prompt.
That's weird.
Yeah, really weird. And then you have to specify the types. And this is like DSPy input field, DSPy output field. Right? Once you've created a signature, that is your prompt, and it builds the prompt from that. But once you've got it in that format, you can swap out models really easily because it's literally the same signature, and it has this adapter underneath that kind of makes it run on any of the different LMs. So you don't have to worry about how does Google do formatting of inputs and outputs, how does OpenAI, which is nice.
Cool.
But the really big thing is the optimizer. So once you've told it, here are the inputs, here are the outputs, and you've given it an evaluation metric and a data set to evaluate on, it can automatically improve the prompt. So that's the real payoff.
Yeah.
Once you see that magic in action, you're, okay, now it's worth it to me to go through all this extra effort.
Yeah.
And you can regularly see pretty easy, like a 10-point percentage increase. Like you can go from, say, 40% accuracy to 50% accuracy, or in some cases, I've gone from 50% accuracy to 90% accuracy. The really difficult thing about DSPy as well is just that it forces you to really think about what you actually want out of your program. And quite often, when people struggle with DSPy, it's actually because they're struggling to specify what they want their program to do. What is the evaluation metric I want to use to define whether this program is working or not? And formalizing an evaluation metric, most people, when they're building AI tools, are doing vibe-based evals, right? This is what I do. And this is what you should do. Like in the beginning, you should say, hey, I think the output looks good, or I think the output looks bad, or my CEO thinks the output looks good, or he's noticed in these scenarios it does badly. So you start with vibe-based, and it's very hard to go from like my CEO likes this to we have a formal data set of inputs and expected outputs, and we have an evaluation metric that can check whether the outputs are good given the input. So like that is actually the hard part, but that's the hard part of building AI applications.
Sure.
It's not the DSPy's fault.
Yeah.
That makes sense.
Okay. That makes sense.
Yeah.
That is like where my mind trips up. I'm like, okay, so this describes something, but I'm used to like being in the details, and this is actually saying, no, don't be in the details, let us do the details. But I'm like, how do I even steer it?
I think a lot of the tension DSPy comes from the fact that they've almost accidentally built the world's greatest prompt optimizer.
Yeah.
But what they really want to be is like a full framework. They want to use this domain-specific language and not care about the details, because you shouldn't worry. You can just compile the program with a different model if you want, and don't worry about what the program did. Like just worry about whether the outputs have good evals or not.
Yeah. So one question, because LangChain is also, oh, don't worry about the details, but like at some point, no one was even understanding what was going on, and no one was like, yeah, it does something, but no one knows how it works. I'm a little bit like worried that it's like a LangChain thing, whereas sure, like we promised a great library, but if no one knows what the hell is going on, what's the value? So I'm curious what your take on that is as well.
Exactly. Yeah. So I used LangChain a lot early on, and then I like started digging into it, and I was like, wait, hold on. They've just wrapped the Python length statement in 100 lines of code for no reason. yeah, I always have this love-hate relationship with LangChain. But I would say where DSPy is fundamentally different from LangChain is that LangChain is like, just use our framework and it will make everything easy. Don't worry about the details. But sometimes you really do have to worry about the details.
Yeah.
But they're not really giving you anything in return. DSPy is giving you the optimizers. You genuinely can ignore the details if you have a good evaluation metric. And that's the key. And I would say where DSPy is really useful is if we have a formal evaluation metric that you trust. And
with Core, we have one, which is, did it guess the category correctly, which is a categorization, which is super easy. So I would say probably for a use case like that, it's probably ideal, right?
Exactly, yeah. There are a million different ways to build AI applications. And what I found is, because I was working as a prompt engineer for the past few years, is basically like a single pattern that you can just use and ignore everything else. This is the evaluator optimizer pattern. And what this solves is quite often the task you want to do is fuzzy. Like there is no like real formal evaluation. If you're doing a blog post generator, you could check the length of the blog post, but like how do you check whether it's a good?
What are you optimizing for? Yeah.
Exactly. So the way I would approach that typically with clients is I would say, okay, who's your domain expert? Or it might be the CEO, it might be someone else. So like I worked with a team of psychologists, for example, to do like a personality quiz type thing. And their time is really valuable. So you don't want them like manually evaluating every single response. What I started to do was this LLM as a judge type pattern. Don't worry about evaluating the actual generator or the optimizer in this case, like the thing doing the task. Instead, build a judge to replace the domain expert.
Yeah.
Right?
And
so
do you fine tune that
prompt.
normally, or is it like prompt? So you prompt that, or you fine tune that, or you actually use DSPy to?
Exactly. So that's also a DSPy program.
Okay. So you just you do that as well.
Yeah, exactly. So like the judge will check whether it passes the test.
Yeah.
And it'll give you some sort of score. So with my DSPy metric, like the LLM judge is my DSPy evaluator. So it allows me to do the fuzzy, as long as the judge agrees with me or agrees with the domain expert most of the time, 80%, 90%, then you can trust it to do the optimization. And it doesn't cost too much, especially if you can get the judge working with GPT Mini or one of the cheaper models. And it's usually possible. It's actually a much easier job to evaluate whether something is good than to create something that is good. Like P equals NP.
Yeah, and this is in a sense of where you need LLM as a judge, because obviously categorization, you don't need that.
Yeah, exactly. So categorization is like a judge type task.
Yeah.
The fuzzier type tasks, like the example I'm using today, I've got like a notebook that I can share afterwards, is telling a joke, getting AI to tell a funny joke. If you ask it, it just uses dad jokes and they're funny, but like not real like stand-up comedian type jokes. The first thing you want to do is train a judge to check whether the joke was good or not, like just 1 or 0. It's really simple. It could be really simple.
Are you always binary, or is it just true, false?
I actually found binary works much better, and it's actually better to just stitch together a bunch of binary evals than it is to use a Likert scale or rate this 1 out of 5, because LLMs, they tend to be too positive, and it's like everything's a 4. So I just do 1 and 0 quite often, and you can build up more weights. So you can say, I don't know, if you're generating like an article for every, you could say, what are all the different things that I care about in terms of a good article? Like it needs to have a catchy hook at the beginning. It needs to be this length. It needs to be, you can actually string all these things together into one master eval and weight them and say, okay, like catchy hook is 80% of the value, whereas length is like 10%, whatever. So that's the way I think about it. Cool. So let's jump into the code. Install DSPy, and then
what about sentiment, like positive, negative, neutral, or is that too much? Should it be
the way I see that is still like in a way like a classification.
Okay,
Yeah, I would say it's important that it's mutually exclusive and collectively exhaustive. Yeah. As in, there's no ambiguity between.
Yeah, exactly. Yeah. Okay. Makes sense. Yeah.
The way you set up DSPy is very easy. It's just provider /GPT for a mini or whatever one you're using. You can set up multiple, and you can use one as the teacher for the optimizer and one as the student to do the task. I'll show you that in a second. But you just generate it, and you can put your prompt in. So you actually can just use DSPy as like a scripting language, right? You don't have to worry about you don't really need to use it like for optimizers, right? And so I use it quite often now for like throwaway programs and like Python experiments and stuff, which is nice. There's a couple of nice features that DSPy has straight out of the box. One is that it's probably like the easiest way to get something working on Azure or AWS or something. It's literally just add a couple of more environment variables. And also, if you wanted to see how this run on another LLM, you could just add in Anthropic / Claude Sonnet, right? It also has caching built in. You can see how fast that ran, right? But if I maybe change the temperature, so that has like default 0 temperature. If I do 1, it'll run again.
Right.
Because I've changed one of the parameters, so it will skip the cache. And you can also do cache equals false if you want, but you see how fast that it just loaded that from the cache, right? It can save you a lot of money when you're doing experiments, even if you didn't remember that you had used that combination before. Or in optimization, it happens to have a cache hit. It will just use the cache version, like it won't cost you anything.
Cool.
So that's interesting. Then to create a program, you can actually just do it in one line if you want to. So this is a basic joke program. It just takes a topic and then gives you a joke, right? So everything on the left side of the arrow, it just turns into an input variable, and everything on the outside, it turns into an output
so is this their DSL? This like input
arrow? Exactly. They've just added that as well. Again, extra confusing, but for convenience, it's quite fun. And if you wanted to say, I don't know, comedian, you could do that, and then literally like the program will just work. So
I really don't like that.
Yeah, it is terrible. But
So I use Ruby. I don't like Python, so I will use DSPy RB, which is is in Ruby, which has a way nicer way to do this. They don't have a DSL in strings; they just have it. Like in Ruby.
I think so. Yeah, and I have a couple of hacks for the workarounds for doing it the more Pythonic way. You can see this is the type of dad joke it has. Why do Python programmers prefer dark mode? Because light attracts bugs. Right? It's classic. Now, one of the fun hacks to get use out of DSPy is you can just see what prompt was run the last. So this is n = 1. This is the last thing that was run on the LM, and that's a global thing. And so you can see the actual prompt here. This is what goes in. Actually, it's probably better if you do the scroll bar on it. It's turned that whole thing into literally just the system message here. Your input fields are topic, your output fields are joke, and it's given the types. All interactions will be structured in the following way. By default, it uses like this kind of markdown type thing rather than like JSON, but you can change it to JSON if you want. This does tend to work better, actually. It's like JSON mode, I think it ends up making it a little less intelligent, is what people have found testing. But yeah, then puts in the user message for you, and then you get the response. The really nice thing is it's all automatically formatted and then all automatically parsed afterwards as well for you.
That's cool. Do you look at these like normally before running, or like to see if you can optimize it, and how do you see if it's good or not?
I used to really hate this because I don't like the style that they use, but it does. Now I just use whatever they have like straight away, and then it tends to work okay.
So
I micromanage my like really important prompts, like the core prompt at Rally is not using DSPy, but like I run all my experiments with DSPy, and then I find something that works, and then I'll incorporate that into my main prompt. Yeah. So because it's in this format, it can go and optimize this. So one of the optimizers adds few shot examples. So it'll test a bunch of your examples that you give it, and it'll see which ones are the best, and it'll add them. But it automatically puts them in as user message response. So you don't have to do all these convenience methods that you might have to do normally, which is quite nice. Cool.
Yeah, basically, so the optimizer you run first, and then you store that version or something like that.
You can, yeah, right? Exactly, yeah. But this is my way of like more Pythonic way of creating DSPy programs. I just create the fields and the instructions, and then there's this like buried deep in their library. There's like this DSPy.make signature, which like doesn't appear in the documentation anywhere, but works. And so you just give the signature name of whatever you want, the instructions, and then the fields. And it does use all of this. So like actually like some of the optimizers are program aware, as in like it shows itself what the program looks like. So even the name of the program and stuff. So like what you name things is actually super important to the DSPy prompt.
It's funny because that's how the Ruby version works. You have a class that is the signature with an input and an output and a description, and you run that, which makes more sense to me. It's like this.
Yeah, so you see here I put .predict. This is just like the base
You
module.
could chain of thought or whatever there as well.
Yeah,
Right?
but you can change that to chain of thought, and then now you have, yeah, so I've just printed output joke, but if I just print what is output, it's a prediction object with reasoning and a joke. So it's put the reasoning in first. That's the really cool thing, is like they have the React pattern for agents tool use. They have samplings where it just generates 5 versions and chooses the best. They have things like that. So they have a lot of these prompt engineering techniques that are built in, which is quite nice. And it's just a one-liner to add them, which is useful.
Yeah.
Cool.
Ever use multiple predictors and then go from there, like in a multi or?
Yeah, exactly. Yeah. So you can basically, once you've created the signature, like then any valid Python object can be a module, essentially. You can string loads of different predictors together, create like complex workflows. That's where you get more into the LangChain type stuff where.
Yeah, like multi-step and
together.
like synthesis and all of that stuff. Yeah.
Exactly. Yeah, just to show you, like I just brought in Gemini Flash and all I needed was my Gemini API key. I don't need to worry about how Google's currently doing stuff, which is batshit. So all good. It's really nice. And you can see here, by the way, you can have a globally configured, like I configured the LM up here somewhere. Yeah, DSPy configure, and it will just use that one automatically. But you can also just run it in context. So you say with DSPy context LM equals Gemini LM, then it will just use Gemini for anything in there. But like the OpenAI is still configured as the main.
Yeah, makes sense.
Yeah, and some of the modules and stuff that you can pass in the LM, but I found it's inconsistent actually.
Yeah. So
cool.
you can do different steps in pipelines with different models and stuff like that.
Exactly. Yeah. Yeah. This is like the chain of thought example, which we've already put in there, and you can print out the reasoning. And because it's all automatically passed, you can just do like output dot reasoning, output dot joke.
Yeah.
It's quite nice. So you really don't have to worry about the internal.
And is there a cycle, feedback loop where you give feedback and it looks at the reasoning and sees if it can optimize from the feedback and the
exactly,
reason?
yeah. So some of the optimizers work that way. Yeah, and I'll cover that. But it's more of a static thing. Like you run an optimization job. Like there's no active learning.
Yeah, but for example, if I have like hundreds of people saying things, this summary was like needed something more like that or something like that, and I had the chain of thought and everything also saved, I could run it once a while to update the prompt with an optimizer to like optimize for that output and more.
Yeah, exactly. Yeah. And you start to get into this really healthy kind of virtuous loop where, because you have the eval metric, you can either make the eval metric perform better or to cover that new use case that you've seen coming up, and then you can run the optimization job again. But you could also go back and change where the program works.
You can start from, you can use a different optimizer altogether, see if that works.
Or try it with Gemini, see if Gemini does better or whatever it is.
Yeah.
Cool. Again, this is like stupid, but the way it works, this is actually how you build a real kind of DSPy program. You create the class, with this is the instructions, and then this is the input field, this is the output field, and then you create another class for the module. And it took me a long time actually to kind of get my head around why this is necessary. But essentially, this allows you to build programs of arbitrary complexity. The DSPy module is the base class that chain of thought and predict inherit from. So it's a way of you to add your own prompt engineering techniques to it. So you just define an init, and it inherits from the module. And then like in this case, I just create the joke generator, right? And then you just have to define a forward method. And the forward method basically just takes the inputs, in this case, just topic, and then gives you the outputs.
You can pass it to any
this is a simple one, right? It just does the prediction and then ignores the chain of thought and just returns the joke.
Yeah, but you could call another predictor or do whatever you want there as well, right?
Exactly. You can see that I think the result is basically, the same. Why did Python script need therapy? Because I had too many deeply nested if statements, couldn't handle the indentation. Anyway. Cool. So that's like just getting a script working. This is where it gets really powerful. So here what I'm doing is I'm training my optimizer, because I think this in terms of, we used to have test-driven development, now it's eval-driven development. Like you have to formalize your eval, and if you formalize your eval, then you can train an arbitrary program, whether it's fine tuning, and actually DSPy does the fine tuning for you as well. They have this like better together optimizer, which does both fine tuning and prompt optimization. That's cool. Crazy. But like you actually, funnily enough, like I find that prompt optimization almost always beats fine tuning.
Yeah, I've never had fine tune work in my work.
Unless you've got like thousands. Like I think there was a paper that said that until you have 2,000 data like inputs and outputs lines, prompting beats fine tuning.
Okay, great. Yeah.
What I did, and this is another little hack that I do to build a data set, is I just went online and found a lot of funny jokes, and I used a deep research here and then told it to give it into Python. So I got like the topic, the joke, and then the comedian in here just for attribution. But so I got it to create, I think it's like.
Well, you look like Ricky Gervais if you.
Yeah,
I
was told that once actually. I'll take that as a compliment. Not that you're saying I'm a
oh, it's a compliment. He's great.
And then I took the unfunny jokes. Quite often the task, it sounds like a complicated task to build a data set, but quite often it's just that you need to go and pick out, like select things that you think are good, and you didn't even have to really explain why you think they're good. And then you just have to, then as the things that are not good, you just have to generate a bunch of GPT answers, because that's what you're trying to get away from. You're trying to get it to not sound like ChatGPT. Yeah. So here I literally just got, I said to ChatGPT, I'll use Mini just to make sure it was especially dumb. Like, just give me a bunch of jokes on these topics, and then that's how I got these. So that's a really good hack for building a.
Why was the belt arrested? It held up a pair of pants. So
There's a couple of useful things to think about here, and the name is inconvenient. Like in the documentation, they don't really explain like what it means, why you would have a training set versus validation set. But as best as I understand, training set is the data that you give to the optimizer to train on. Like it can see that data, it will evaluate that data, and it will use some of those examples when it's optimizing. Like it'll add them as few shot examples.
Right.
Validation set is you give that to the optimizer as well, or you don't have to, but you can give it to the optimizer as well, and it uses that as the test set. So it will it'll look at the data, try a bunch of things, and then it'll run a test on the validation set. If you don't give it the validation set, it will just run it on the full training data, so it can end up costing quite a lot. So that's one of the primary reasons. Also, I think the results don't generalize as much if you don't have a separate test set. And then the reason why you need a development set is that because it also sees like the test set when it's running the results, sometimes it will bleed across and it won't give you like really good like generalization. Like you'll get good optimization scores, but when you try and run a new joke or whatever, it won't be very good. And then so the development set is what you use, the optimizer never sees, right? Like you just create a new, like you just run an evaluation yourself after the optimizer is done. And that's really important, I think, for proving to the client or proving to stakeholders that like it actually did do a good job.
It's not part of the loop. You need to have the evaluation step in the end, but it's just running it. It's not training or optimizing or doing anything.
Exactly. So the way I split it usually is I'll try and get like more than 100 examples or 200 examples of good versus bad, and then I'll split it 60, 20, 20.
Yeah, you do new examples, I assume, right?
Yeah, exactly. Yeah. So you can see here we split this out. A couple of weird things. Yeah. The way that DSPy wants the examples is also like a bit odd. So you see here it's DSPy.example, and then you just give the different parameters. In this case, because it's the judge, we want this funny equals true to be the output. And then you just do dot with inputs and then list the ones that you want as inputs. And then it will assume the funny is the output.
And examples, you always use examples for optimization, right? Or
yeah, that is what like a data set is for DSPy.
That is the whole point, right?
That's how they format it, yeah.
Exactly, yeah.
Yeah, and they have like internal stuff that will turn that into a pandas data frame, essentially. Yeah. Cool. So we've got our data set. Just here's an example. We've got the topic, joke, and whether it's funny or not. So we create our judge, and this is a case where like actually it's convenient to do the inline thing. We're just taking, because we don't care that much about this judge, we just care about whether it's accurate. We don't care how it gets to accuracy necessarily. So we're just giving a topic, a joke, and then we're saying whether it's funny or not. You can also set types in here as well. So I set this as a Boolean because I found that otherwise it gives you back like a big spiel of like why it's funny or not
Yeah.
funny. You can see here, like in this case, judge says it's funny, true, actual ground truth is false. So the judge was wrong here. And I made it chain of thought because chain of thought tends to really improve the results of judges. It thinks it's funny, but it's not. So we need to train our judge. So we can actually do an evaluation of our judge. The evaluate convenience method is like really helpful because it runs in threads. So it runs in parallel. It makes it run a lot faster. So it'll run 8 of them at the time in this case, but you can set that to whatever you want, which is nice. And then you just pass it in a metric development set, as in what this is like the one that we kept aside that the optimizer won't see, if that makes sense, the final judgment. And we can see that here it's 51% accurate. And you can see the actual examples here. This one wasn't funny, but the judge predicted true that it was funny. So it got that wrong, right? This one was true, it was funny, and it predicted that it was funny, so it got that one correct. The nice thing about judges is that they can have an exact match score. And the way I've set the prediction metric up is, again, specific to DSPy. You have to have this like trace equals none. So you can set that. So that allows you to basically set like a different metric response if the optimizer is evaluating versus if it is like learning from the failures. So if trace equals is not none, then it's like learning. So you could give it like a more strict evaluation criteria, because the reason why you do that is, like in this case, it's just exact match, so it's easy. But the reason why you might want to do that is maybe if you did have an evaluation metric, which is like rate this 1 out of 5, you have a score then. But when the judge is learning, it's deciding what few shot examples to put in. So you might want to say, I only want 5-star ratings as my examples, right? So you don't have to do that, but that's why that's there. And it automatically will pass in the prediction and then the gold, which is like essentially the ground truth, like from the data set. So in this case, we're just checking whether like prediction funny equals gold funny. So that's like the simplest possible eval metric. Cool. So we have a judge that's wrong half the time. How do we make it better? This is where we're bringing in optimizer, and this is the simplest optimizer. It's just called Bootstrap Few Shot. All it does is it just adds in actually creates a couple of few shot examples, and then checks them against the evaluation metric. If the evaluation metric is correct, then it will pass. It will like add them into the prompt. So when we run that,
You think it synthesizes judge to passes?
yeah, exactly. Yeah. So yeah, here we go. So we have max bootstrapped demos and max labeled demos. Max labeled demos is like demonstrations, as in examples from your data set. So you're allowing it to add up to 16 few shot examples from your data set, from your training data set. And then max bootstrap demos is you're allowing it to generate new examples.
Yeah.
The data set, but still pass your metric.
So would you ever run this without examples, or you will always add examples?
Because you always add examples, yeah, because it needs. I guess you could just make the max label demos equals 0, and then it should be able to do. But yeah, I mean it's.
But you would never do that. It's just not a thing.
Yeah, like
I
would even go to the length of I would go and run the program like 100 times to generate the data set and then run.
Yeah, and then you manually pick or whatever the examples. Yeah.
You can also set a few things like, so put the metric in there, but you can also set a threshold. So you could say, I just care about 80% accuracy. So if it gets to 80% accuracy, stop optimizing. You could also set the teacher. So you can say, I want O3 to be the teacher. And but I still want Mini to be the task. Yeah. And so it's distillations. Whenever it generates a bootstrapped demo, it will use GPT-3 to generate that. Oh, sorry, it will use O3 to generate that. Yeah. So that is like quite an effective approach.
And how do you choose the number of examples and what examples, and when do you change the examples?
I find it's like very much an art rather than the science.
What do you do?
I found it like really weird results sometimes. But yeah, broadly speaking, I'll try it with the default and then I'll diagnose. So there's a couple of different optimizers. By the way, this doesn't change the instructions. This still keeps your instructions, but it only changes the few shot. And usually that's enough actually for classification tasks. I would say typically that you want like at least 5, maybe more like 10 examples in the final prompt, maybe more than that in order to get good accuracy on a classification task. But you don't want too much. obviously there's a cost to running this. This just happened instantly because this is a deterministic optimizer. And because I've already run it before, it pulled from the cache. But like this, it can actually take 10 minutes to run or something, and it can cost, like, it can make a few hundred API calls or a few thousand API calls. So it can actually cost you into the hundreds or maybe even thousands of dollars, depending on how big your data set is. Yeah. So with DSPy, it's forced me to just basically be as dumb as possible. Don't care about the prompt, like just do the inputs and outputs and see if it works straight off the bat. If it doesn't, then run an optimizer, see if that works. If it doesn't, run a more powerful optimizer, and then go, okay, I'm going to try and run a few experiments. I'll do it with 16 demos, or I'll do it with 5 demos and just see what works. So I only apply the complexity like on demand. It's almost like just in time addition of complexity.
Yeah. And like, for example, you made one last year or like half year ago. Do you ever go back to the example? Because people do give feedback and things do change and models change. Like, when do you decide to redo this or add other examples?
Yeah, I would say typically once you I would rerun a prompt when we discover a new dangerous edge case. Oh, everyone's complaining about this now. So then I will do a job just specifically to solve it. Or if I've collected more than 50 new user responses, because you could have a whole system here where you have a thumbs up, thumbs down button on your
that's what I have. So I'm
map,
thinking,
right? And then that generates the data set for you, and then you just rerun and see how well it does.
Yeah. But yeah, like it is like a continuous thing.
Yeah, the dream is what I want to get to with our system is it's just running overnight every night. It just keeps improving, and I don't have to worry about it.
Yeah, and really it's like the examples. So how do you then choose the examples? Or like you just give all the examples and say you figure out how.
This optimizer chooses the examples for you.
So you don't really need to deal with any of it. You just say whatever the default is, 10 or 16, whatever that is.
Exactly. And I find for simple tasks, Bootstrap Few-Shot works pretty well, and it's the cheapest one to run, so it's like very easy. It's pennies. You know. Bootstrap Few-Shot random search works much better for more important tasks. And again, it only chooses examples, but it adds like a random search component. So it'll go and it'll find a new, like this one just goes through the examples and chooses one, but it might be at a local maximum. Like random search actually just literally hops around your data set and like picks out. So it's more compute intensive, but it does a really good job.
Yeah.
And then, so that's optimizing the judge, and here we go. Obviously the eval would run a lot slower if it wasn't cached, but we have, even just adding a few shot examples, like we have 92% accuracy now.
Yeah, that's cool.
Wow.
So that's amazing, right? Like you just go, we didn't even have to think about it. We didn't even look at the prompt. And now we've had an 80% improvement with a couple of lines of code. That's the magic.
Yeah.
Right?
I'm going to for sure use this for categorization, like next week.
Yeah, so categorization is perfect, but then every fuzzy problem also is a categorization problem, right? So now like the judge is the categorization problem. We can now use that to make and you'll see it won't work as well and it's more intense, but it does lead you to a path to get the fuzzy tasks under control. So now I've just created a new metric, which is the judge score. And again, literally just saying the judge, like I'm using my Bootstrap to optimize judge, right? Like this program that we created.
And that's the optimized.
Yeah, exactly. Right? That's the final optimized judge, right? That we created here. And then I'm just using that as a program, right? So I just get my judge result. So I pass in the topic and the joke, and then I give a 1 or a 0, right? So that's really great. And then you can create a data set. In this case, I basically filtered out the examples and I changed the inputs a little bit, because before, if you remember, we had the topic and the joke, and then we check whether it's funny or not. And in this case, I'm just passing in the topic and then getting a joke, right? So I had to create a new data set, the topic data set, and the only input is topic, and then it would generate a joke. The other thing I did is I filtered it. So I'm only giving few shot examples where the joke was funny, because I find that it's actually really detrimental sometimes to give negative examples. You want it to only have positive examples, because when you give it negative examples, it tends to follow that negative example weirdly. It's like almost to say, don't put your hand in the toaster, and it goes and puts its hand in the toaster. You know? Yeah. But you can experiment with that.
On that case, like edge cases, how would you choose to include edge cases in the example, or like you just include them and it will be handled?
Yeah, what I would do is I'll take the edge case, I'll get your domain expert to rewrite what should have been the correct answer, and then use that as the few shot.
Yeah, because otherwise it's confusing, or like it will throw it.
Exactly, yeah. Or you could do like a rewriting type prompt, which would be again another DSPy program where it takes the wrong answer and rewrites it to be the correct answer. And then you can see in terms of optimization that, so what I've done here is this is taking the topic dev set, which is those examples that we had before. So literally just the exact dev set, and it's just given the topic. So it's just taking those topics, and it's found that out of 51 topics, only 20 of them resulted in funny jokes. So we got 39% funny score
From our joke generator.
from our joke generator, a baseline, right? So now we're using the big guns, MiPro, which is like a Bayesian optimization algorithm that very smart people worked on. And this not just does the optimization of few shot, but it also changes the prompt instructions. You can actually just run this as a prompt instruction optimizer if you want. By just setting max bootstrap demos to 0 and max label demos to 0. In this case, I set it like you can also do light versus medium versus heavy. Like I set it heavy. Because it's non-deterministic, you want to set a seed as well so that like you get the same results. And otherwise, every time you run it, there's not going to be any.
It's a little bit worse or better.
Yeah, you can also set the initial temperature. So it starts at that temperature and then it will try different temperatures at other sides and things like that. So it also optimizes those parameters for you, which is quite nice. But pass that in, and then I must have messed something up because it's running again. Here we go, great.
$500.
Yeah, exactly. Oh no, sorry, I was just running through the cache. Cool. Yeah, no, I mean I'm using mini, so it's fine. But that could be like $100 mistake if you're using O3 or Pro or something. Yeah. Yeah. Just to show you, like again, a lot of this won't make sense, but you can see it's super optimized the instruction text, select the few shot examples, and balance between different optimization strategies. First, it starts like bootstrapping traces, meaning it's generating new few shot examples, and it'll have a certain number of attempts to get like a funny joke. And then it's like doing that a bunch of different rounds. And then it's proposing instruction candidates. So we use the few shot examples from the previous step, a generated data set summary, a summary of the program code. So it's like program aware. It can see what the code looks like of the full module. And then a randomly selecting prompting tip to propose instruction, right? So like you can actually override those as well if you want to subclass MiPro, but I'm too afraid to try. And then, yeah, so it's proposed instructions. Like it did have tell a funny joke about the topic, but then it came up with this one: generate a humorous joke related to the specified topic, suitable for a general adult audience. Be mindful of potentially sensitive content, right? So that's its prompt, its new prompt, and then
which model was it using to generate this prompt?
So by default, it's just using the same model that you passed, but you can set that. So you can choose the prompt model, you can choose the teacher model.
Right.
And so the difference is the prompt model rewrites the prompt and creates candidates. The teacher model generates new few shot examples.
Okay.
Yeah. So it goes through all this, and you can see it runs for a long time, right? Lots of trials here. You can set the number of trials and stuff. But once you have that, you can run the optimization, and then
49%.
yeah, so that's actually better for some reason. Maybe I didn't run it with that seed before, but yeah, it actually went up from 39% to 49%. Yeah, it did get a lot funnier. It still does a few dad jokes and stuff like that, is what I found. But the way you would go to improve this is you would improve the optimizer, right? Because we only had 90% accuracy, and we also had pretty easy examples where the dad jokes are very obviously bad and like the comedian jokes are very obviously good. So we don't really have that many in the middle. So I would go a bit more fine grained now if I wanted to improve it further, and I would give it some harder examples to train on.
Can you see some of the jokes that you think?
Yeah, I'll show you that in a sec. But
This looks great. Show me.
Yeah, show me the money. Yeah, this is like the basic one. So topic was Python. Why did Python programmers prefer dark mode? Because light attracts bugs. MiPro is like, why did the programmer quit his job? Because he didn't get a raise.
It's not funny, but
that's better. Yeah. So this one's a little bit better. Why did the coffee go to the police? It got mugged. I like my coffee how I like myself, dark, bitter, and too hot for you. Okay, this is a bit better. Why did the bicycle fall over? Because he was too tired. And then MiPro said, I hate when I lose my motivation to exercise. It's like, where do these extra 10 pounds keep coming from? I think that's much better. But yeah, anyway, so you can see that it is a little bit harder to get like for those fuzzier tasks, but we did. It's not to be sniffed at, right? We went from 39% funny to like over 50% funny, almost 50% funny. So that obviously you keep working on this, but like the fuzzier tasks are just harder.
Yeah, no, I mean, that it was definitely interesting. So what I'm taking from this is the judge is like everything.
Yeah. Actually, I'm like radicalized on this to the point where I actually don't think data matters. Everyone says it's all about your data, your unique data. I'm like, no, you can generate infinite synthetic data if you have a good judge.
But that's
really,
also,
and that's what
you
actually
need data for a judge, right? You
Yeah.
need to get good data to create a good judge, which is
Yeah,
data.
you only need the data to create a good judge. Once you've got a good judge, you don't really need to care.
You're
about
good.
more. Yeah. So and that's what like you hear from the labs as well. Like a lot of them are doing synthetic data now.
I've two questions. One, how do you productionize this? Do you export like the prompt and you run that?
Yeah, so I don't productionize this. Like I've never put a DSPy program into production for any.
Exactly, yeah.
I could never convince them to do that, and I wouldn't want to.
No, I don't want that
because it's like a kind of complicated. And yeah, maybe I'm warming to it. Like I actually have an internal tool that uses DSPy end to end.
Yeah, okay, but
and there is a way to get it running with a fast API. And so one of the things that is important is that you can save the program locally, and then that creates a folder with all the metadata and the pickle of the program. If you share this folder with someone, they can just literally just do this. They can just load the joke program, and then it runs perfectly on their machines.
Okay.
But can I export a prompt? Is that something you do?
Yeah.
Because
So this is where my special hack, and this is like the.
that's what I would want.
So I pestered Omar like insistently because he like really hates that that people just want to get the prompt out, and it's not that easy because even in inspect element it shows the outputs and stuff, and it's hard to construct it programmatically. So anyway, he was like, you could just do this, and I'm like, okay, fine. So you basically pass in to the chat adapter, which is what it uses underneath the hood, the format function, and then you get the signature, the demos for all of the named predictors essentially. So it's don't worry about it too much. Your eyes will bleed if you look at it, but basically if you just run this, then it will like you'll have the full.
And this is the same, like this is exactly the same.
It's exactly the same. It's got the system message and it turns it into the user and assistant messages as well. So
and for variables, like I normally use Liquid, but like it uses something else, I assume, or
it doesn't use variables importantly, which is interesting. So
so how do I custom? So how do I make a use of variables, or like how does it even work? It just has instructions, and then you have a user message, and then it will follow up with whatever the reasoning and things is from the user message. So how do I trigger this thing then?
Yeah, exactly. So you can see here it doesn't like use variable, like even this actually isn't a variable, it's just formatting. And then the only place it uses the variables are here. It just puts in the inputs and the outputs. And then when you generate, so you can see that the user message is like just topic like this, and then religious satire.
So I have to use the exact same format.
Yeah, you'd have to use the same format, or you could use the DSPy chat adapter if you wanted to, or
I replace those things with liquid text,
with like real stuff, like how you'd normally prompt. Yeah. You can also use a different chat adapter, so you can also create your own chat adapters. Like you can make it work, automatically convert it into your own format the way you like to do it, if it's markdown or whatever it is. So you can see we've got the prompt out here. We've got this is just the messages stream essentially. So you could actually just pass this into ChatGPT as well, also into OpenAI.
So I have one other question.
That's us, yeah.
Which is, it's interesting to see that it's doing its few shot examples as assistant, user assistant, and user assistant.
Yeah.
Is there a way to be like, I want the examples to be inside just the system prompt?
You just have to change the chat adapter.
Okay.
So yeah, and it's all open source, right? So you can see what they're doing, and you can just subclass it, which is quite nice. But yeah, I found actually that it works better to just put the few shot examples in the system message. It tends to follow it better. So I don't fully agree with the way they've done this, but this is like the way that you're supposed to do it. But like again, it's one of those hacky things where like I found that doing it the wrong way actually sometimes works better.
Works as well.
Yeah.
And
so again, like the nice thing is that you can still benefit from everything by just changing the chat adapter. And if you change the chat adapter and optimize with that, you can recompile the program, and then it will just change the few shot examples. It would change all of the output input. It would change everything to just match your format, which is
because the chat adapter is used when running the optimization.
Exactly. So every single time any prompt runs from any of the optimizer processes, sub-processes, it will always go through the chat adapter to the LM and back.
And okay, one last question from me. So I have memories specifically tied to users, and I would inject memory into the context as well to personalize things more. But how would memory work, or how would that work with an optimizer, or you just leave it out completely?
Yeah, so no, I've thought about this a lot, and the way you do it is you give it as like a specific field in DSPy. So they actually have a history field somewhere.
They have memory, like there is a concept of memory.
Yeah, and they've got a tutorial about memory, but what I've used for those, because we also have the same thing with Rally, like we have the past chat history.
Yeah, exactly.
There's a specific DSPy history, which will then format it in the correct way as a message stream.
Yeah, okay, but how do you like we have 5,000 users, like how is
so the way you've got to think about it is it's like a Excel sheet, right? For every interaction with the user, you have the same, as long as you have the same columns, like the input from the user is this, and then the memory of the user is this, and then maybe you did some RAG, right? So like the RAG result is this column, and you can actually build the RAG into the program as well. So you can do all of that stuff. You can have, actually, I think they've got an example here. Yeah, here's an example. Oh no, sorry. Yeah, RAG. So like here they've used Colbert as the RAG thing, and they've just passed that in to search Wikipedia, right? Or they have agents where it's like they have evaluate math and search Wikipedia, and then they pass them as the tools, right? You can actually build whatever program it is you want.
But you just need to make sure your examples contain the user ID or something like that, and then it can do whatever memory lookup for that user, and then it's included in the optimization.
Exactly, yeah. And so that's nice because it will make it extra generalizable in terms of it will, because the memories are different every time, like it will, I think, really truly learn the task, if that makes sense. Yeah, but like every row is just a user interaction and what context interaction had at the time. Yeah,
and you just include it or do it however you want.
Yeah, exactly. Yeah.
So I have a question if you have the time.
Yeah, sure.
So you say you don't use DSPy in production. How do you go from the prompt that you have in production to DSPy?
Yeah, good question. Yeah, so typically what I'll do is I'll run the optimization. So there's a few things that I tend to use it for. One is to just script to try different things in different models. So I'll be like, okay, does this work, right? Does, like, I don't know, I was trying to make like a focus group where the agents talk to each other, and it was much easier to just give them a talk tool and then make a React agent in DSPy and then let it run and just see if it worked. So then it just gives me a broad strokes of, does this interactive format work or not? And it's crappy. So I was like, okay, I'll abandon that. It's really good for that. I use it to test out theories of what might work. And then if it works in DSPy, then I'll go into my code and I'll test it. The other way is I'll actually run the optimization. I'll create the eval metric, but then I'll export the prompt like you saw here. Like I'll get the system message, etc., and then I'll just translate that to my format. So I'll just say, here's how I structure my prompt. It's not perfect because you might change actually the evaluation score when you change the format. But it's actually pretty easy to just give this to ChatGPT, like paste it in and say, hey, I got this program from DSPy. Can you just change the few shot examples?
So how do you go the other way? Like, for example, to be more specific, I have my prompt for Spiral. Let's say I have a very fuzzy task that I want to evaluate against. How would I take that and then put it into DSPy to then evaluate against?
Yeah, so the canonical way for DSPy they would say, don't worry about all the crazy stuff that you put in your prompt. Just describe the task as the instructions, like just a simple task. Describe what the inputs and outputs are, and then dump your eval data set, and then create the focus on the eval metric. I found pretty bad results doing that. Like it takes a bit of time to get back up to, if you've got a really lovingly handcrafted prompt, it actually takes quite a while. Like I actually have a joke prompt, which is not safe for work because it's like very good at doing Dave Chappelle. And I even trained his voice, and I didn't release the guy, I didn't want to get sued. But it is like they literally passes the Turing test, and this was back with D4, like before 4, and it's unbelievable. Like, so I still haven't created a DSPy joke generator that beats that, but that took me like days. So, like I just love comedy, so I put a lot of effort into it.
So are you basically?
So I would say quite often I use DSPy for the things I don't care that much about, which is 80-90% of my prompts. For Rally, we have a really lovingly handcrafted prompt for querying the personas. and for generating the personas, but you also have prompts for like generating the title. And I'm like, I don't care about that. Like I just use DSPy for that. Or I have a prompt for classifying the diversity of thought and I don't even know what diversity of thought means really in a lot of cases. So like I just use DSPy for that, and I put into my data set cases where the users have complained and sent them to me. So that's how I think about it: is create your classifiers. It's amazing at that. Create your like utility tasks in DSPy. It's like amazing for that. And you don't need, if you don't care that much about it. But just like AI writing, like I still hand write stuff. Like my every article is actually the only thing really that I like write myself anymore, because going to 100,000 people, it's actually like worthwhile to spend a day, and it only takes me a day, because like I don't, would my life really be better if I like managed to get that down to a couple of hours, but like maybe the quality won't be as good. Yeah. So like for things you really care about, I think you can still beat DSPy, but like I would say increasing amount of things I just don't care about. Yeah.
So if I have a categorization thing, would it be better than hand doing it, categorization, or you would say still think it's better, it will be better if you hand?
I would say I haven't met a classification task that DSPy didn't completely blow out of the water.
Okay, so I should use it for Cora email classification. Yeah.
I think so. Yeah, I think that would be like a really good place to start. Yeah.
Yeah, the only thing there is like, how do I train it for all thousands of users? Because all users have different rules and different nuance. Like the prompt is dynamic, like my prompt changes per user, and I'm just worried that will mess, like it will generalize something that's really good.
Yeah, to
won't
some
work
degree,
for the people.
yeah, to some degree, I guess like if there is a coherent meta task, as in if most of your users have similar preferences, then it will do a pretty good job of teasing out. If there is some pattern,
Maybe that's
it will do a good job of finding
break
that.
it up in two steps, where it's like one is the generalized version, and then it will do a secondary for things, but that's more costly. So think about it.
Yeah, exactly. But what you could do if you have enough data per user is you could just have a DSPy program per user. Right? Like I've seen that with fine tuning.
And that would be
early
really
on, like say Writer did a really good job of this. They made their own AI models. They had the base model, which was really good at writing, but then they trained a custom model for each, because they're enterprise clients, right? They trained a custom model for each enterprise client on their brand values and their tone of voice. Or you could have, I see AI image companies do this, right? Like they have a custom LoRa per brand.
Yeah, I think that might be the key, and I am going to try that.
Yeah.
Do you like, how costly is it normally to run this? Do you know?
I would say you basically don't really have to worry too much if you're using GPT Mini or Claude Haiku or one of the Gemini Flash. Like that's you're never going to cost yourself more than a couple bucks, even with the heavy optimizers. Where it gets really dangerous and scary is when you're using anything Anthropic like Sonnet and particularly like Opus, right? Like that could be like a few $100 mistake. Or if you're using the big OpenAI models as well. I actually did a big project for a client, which was 5,000 AI personas, and we were just using 4.0. But I did this big optimization, and my credit card got declined because we'd spent like $900 in an hour, and I was like, oh, so I had to ring up my client. I was like, do you have a credit card that I could use? We can't continue. Yeah, it's pretty funny. Yeah, this was like early
really
on.
Funny.
Didn't have
really
any
funny.
money in our company account, so that was a fun
okay, but
and then our product went down because we couldn't afford any more tokens. Again, very fun.
But yeah, my margins are not that big because my product is $15 per month, and I already spent around $2.50 per month in inference. Just so like $1 is important. Also is important.
So I would say that you might want to do like a more of a meta task then, and if you can optimize the prompt once and it gets 50% better for all users,
it's better.
Then like you can arb those costs over like the whole user base.
At least I need to experiment and see, is it worth $1 or $2 once to run, or
to some degree as well. There is you can actually really bring down your actual costs with DSPy. The optimization is an investment, but I've seen it happen where like you could take, like I would take GPT 4.5 because it's good at creative writing, and then I would use that as the teacher model, or I'd use that to generate a synthetic data set.
Yeah,
And then
you
I'd say, we need
distill.
to get almost as good, like 80, 90% good as 4.5 for
Yeah.
that task.
Yeah.
So like distillation, I think is the primary, like classification and distillation are like the two major brain.
I'm
like,
already on the
you
cheapest
cannot
one.
lose essentially. With,
I already use Flash 2.0 for classification.
Yeah, Flash is great, unbelievable. I hope Google keeps subsidizing it. Yeah.
Cool. This is amazing. Thank you so much.
Cool.
Yeah, thank you so much, Ryan.
Yeah. It'll be good to get the recording afterwards as well. We could turn this into, maybe I don't have to write my next every column now. So
Yeah, we should it's like I'm definitely going to try this out next week or weeks, because this is exactly the problem I'm trying to solve, and I'm just lazy to work on the prompt.
Yeah, it is like one of those things where actually similar to vibe coding, like when I first started using Copilot, I was like checking every line, and then now I'm like, oh, I'll just see if Claude Code can do it. And we'll see. I think DSPy is similar, and then, like, I used to care a lot about my prompts, and now I'm like, we'll just see if DSPy can do it.
Yeah.
Cool.
Cool. All right. Thanks, guys.
Yeah, thank you.
All right. Take care.
See you.